forget, when our quiz is, where do you look? Look up there. I got it listed for you right here. What is the quiz going to be on?
Gravity and motion orbits.
Gravity, motion, and orbits, right? So, way to use your resources. Okay. So, looking at the I can statement, what do you think we'll be learning about today?
Gravity and family.
Perihelion and aphelion, right? What does our I can statement say today? Can you raise your hand and tell me? There it is.
Describe the difference between a low and high
Eccentricity.
eccentricity.
Alright. And this word's a little tricky, but you practice it a couple times, we'll get it. So that's eccentricity. Alright?
Eccentricity.
Awesome. So what I need you to do is that orbit worksheet that we did yesterday, go ahead and pull that out. Have it out on your desk.
Oh, this one. You got that on video too.
Alright, so here's the orbit that we made yesterday. Everybody should look like this because we made it together, right? Does anybody's orbit not look like this? Alright, so let's go over this real quick and make sure we understand all the terms on it. Alright, so here's my planet. My planet's name is what? Endor. Any of my Star Wars fans out there? I got a couple of them. We got more of this already. So here's my planet Endor, and this is its orbit. So it just goes around this orbit all the time. Just follows this orbit. Now, if you notice, this orbit is not a perfect circle. What shape is it?
It's like an oval.
Like an oval, but actually, what's the more specific name for it? An ellipse. We call this shape where it's more elongated. We call this an ellipse. Now, an ellipse has two spots that we call focuses. So you got focus 1 and focus 2. The way you can think about an ellipse is a shape. Look up here, everybody. It's like a circle that has been stretched. So you have focus 1 and focus 2. Imagine them meeting in the middle. And when they meet in the middle, what shape would we get? An X. Imagine this whole thing compressing. A circle. So when the two focuses, or foci, are in the middle, what you get is a perfect circle. And then as these focus, or these two focus points, as they separate, what shape do we get? An ellipse, right? And as these get farther and farther apart, you get more and more elliptical. Now we have a scale to describe this. We call that scale eccentricity. So, can we all say it together? Eccentricity. All eccentricity is, all it's telling you is how far apart are these focuses from each other. How stretched is this orbit, all right? And now this scale ranges from 0, which is a perfect circle, all the way to 1, which is like a straight line. The easiest way to show this, so let's say I have my rubber band here. Not a perfect circle. That's pretty close, right? So this is my circular orbit. Now as I stretch it, it becomes more and more of an ellipse. My thumbs, or my fingers, are like the focus. And we pull and we pull and we pull. Now if I pull this tight enough, what's the eventual shape that I'm going to get? A straight line. So let's go over this again. Eccentricity. When it's 0, you have a perfect circle. When it's a straight line, your eccentricity is 1. And everything in between is an ellipse. Okay?
Yeah.
Let's go over some of this vocab real quick. So let's talk about our orbit a little bit. So here's Endor. It's going around my sun, which is right here at one of the focus points. It's going around, it's going around. Now, when it is closest to the sun, what do we call that point? Perihelion, right? Kind of another weird word, but it just means close to the sun. And we keep going and we keep going, and eventually in my orbit, I will be the farthest point that I will ever be from the sun. What is this point called? Aphelion. So perihelion is when you're really the closest you are to the sun, and aphelion is when you're the farthest away. Now, when we look at our total ellipse, there's two different measurements. There's one that measures a line across the long part, which we call the major axis, and one that goes across the skinnier part, which we call the minor axis. If we want to talk about half of it, then we call it semi. So the whole thing is the major axis, and half of it is the semi-major axis. Okay? Everybody with me? Judy, I love the thumbs up. All right. Got a question, Riley? Yes, so when eccentricity is at 0, we have that circle. Those focus points are both in the middle. Yeah, those focus points are stretched out so far apart that you get a straight line. So this and this would be touching in the middle because they'll be so stretched out. Anything in between is a number between 0 and 1. So it'd be like a decimal. Alright, now this whole thing, this whole elliptical orbit is described by Kepler's first law. So I have it written down for you right here. So Kepler's first law is planets orbit the sun in ellipses, with the sun at one of the focus points. So I recommend you write this somewhere on your ellipse sheet right now. Write it somewhere, this exact sentence. Give you a minute to write that down. Darius, you got your sheet? Kepler's first law right over there for you. See it now?
Do I write that on this sheet?
Write it on your ellipse sheet. 'Cause remember, what are you going to be able to use that on?
Notes.